I am Lovepreet Singh from Harvard Convent Senior Secondary School, Bhagapurana. This is the video lecture of grade 10 physics, and today I am going to discuss a topic DC motor of chapter 2, magnetic effects of electric current. So, first of all, on what principle a DC motor or electric motor works? When a current carrying conductor is placed in a magnetic field, it gets displaced, as we have already done in the last lecture. In the last topic, Fleming's left hand rule, we have done an experiment in which we have placed a current carrying conductor in a magnetic field. When a current passed through a conductor or a wire, it get displaced, mean it experiences a force. Then first of all, as you have already done the Fleming's left hand rule, a scientist Fleming discovered a left hand rule by which we can easily get to know by in which direction our force on a conductor is applied, and in which direction is current is going. So in the left hand Fleming's left hand rule, first of all, hold your mobile phones in your right hand and stretch out your index finger. Index finger is directed a magnetic field, as shown in the figure. From north pole to south pole, always from north pole to south pole magnetic field lines travels. So our index fingers directed towards our magnetic field. Then stretch out your middle finger, which is perpendicular to your index finger, as shown in the figure. Your middle finger is perpendicular to the index finger, which tells us the direction of the current. Here in the figure, there is a green color of conductor or wire, and our middle finger tells us the direction of current, which is out of the screen, out of the plane. Then in the last, stretch out your thumb, which is perpendicular both our middle finger as well as index finger, and thumb tells us in which direction force is applied. Here in the figure, the thumb is in the upward direction, so the force or motion of the conductor is in the upward direction. So this is the Fleming's left hand rule, by which we can easily know about the direction of motion, in which direction conductor will be displaced. Next is our DC motor. Here in this animation, as you can see, a coil is rotating in the magnetic field. As I have told you earlier, magnetic field lines are always goes from north to south pole. Here in this animation, coil is rotating anti-clockwise, and this coil is known as armature. This coil is known as armature. As you can see, there is a presence of north pole and the south pole, indicating that there is a magnet inside the motor. Within the poles of this magnet is placed the armature coil. So next, now this armature coil is usually wound around a soft iron core. Now the ends of this coil are connected to split rings. Now this split ring is so called because, as the name suggests, this is split. This is divided into two parts. This split rings next connected to the carbon brushes. Now these carbon brushes acts as leads for the battery across which the entire circuit is connected. So across brush 1, carbon brush 1, in the left side, the positive terminal of the battery is connected, and across carbon brush B2, which is on the right side in this animation, the negative of the battery is connected, as shown in this figure. Splitter 1 is connected to the B1, which is our carbon brush, which is connected to the positive terminal of the battery. Splitter 2, which is connected to the D end of the coil or armature. Splitter 2 is next connected to the carbon brush B2, which is connected to the negative terminal of the battery. So as you can see from the polarity on the battery, current will in this particular direction. This is the working of the electric motor. Current will move in this direction from B1, from positive terminal of the battery to B1, then S1, then to A, B, C, D, and along the wires to the battery. Now if you consider an arm A, B and C, D separately, you will find that the direction of I in both these arms is perpendicular to the direction of the external magnetic field. Here external magnetic field is from north pole to south pole, which is in the horizontal plane, and our current is traveling from A to B and then from C to D, which is vertical in the vertical plane and also perpendicular to the external magnetic field. Direction of the current is perpendicular to the applied magnetic field. However, if we consider arm BC and AD, in these arms current direction is parallel to that of the magnetic field. BC and AD is also in the horizontal plane, and magnetic field from north pole to south pole is also in the horizontal plane. So due to this, no force will act on those two arms. So direction of current is parallel to the applied magnetic field. Now we will find direction of force on arm AB and CD by Fleming's left hand rule. On arm AB and CD, in which direction a force is applied. So in arm AB, current first take the index finger. First of all, hold your mobiles in your right hand and stretch out your index finger of the left hand, pointing in the direction of the magnetic field from left to right. Here in this picture, a magnetic field goes from north pole to south pole. So our left hand's index finger also directed towards the south pole, and then outstretch your middle finger, pointing the direction of the current along AB. So our middle finger pointing upward direction, in which direction the current is flowing. So now if I stretch out my thumb such that it is perpendicular to both the index as well as middle finger, I will find that it gives me the direction of force acting on AB. Listen once again. Now, if I stretch out my thumb such that it is perpendicular to both my index finger as well as middle finger, I will find that it gives me the direction of force acting on this arm AB. In this case, it is into the plane of the screen. It is into the plane. It means this AB coil moving downward due to the force applying on it. So on arm AB, a force acts which we obtained from Fleming's left hand rule. This force acts which we obtained from Fleming's left hand rule, which is into the plane of the screen. It means in the downward direction. Now let us consider arm CD, opposite arm. Again I will show the direction of the current. Now in arm CD, current is flowing in the downward direction. So again my index finger will point towards the direction of magnetic field, and current that is depicted by the middle finger points downward. So if I stretch out my thumb in a manner perpendicular to both my middle finger as well as index finger, I find that force acting on CD is out of the plane of the screen. So I find that the force acting on CD is out of the plane, means in the upward direction, as you can see in this picture. Now the amount of current flowing through the arm AB and CD is same. The amount of current flowing through arm AB and CD is same. The same external magnetic field acts on them. The current is same and also magnetic field is also same. So if both the current and magnetic field is the same, what can we say? The force that act on them will also be equal. If the current is equal, magnetic field is equal, the force will also be equal. Due in the inward direction and another one in the inward direction, like in AB side the force is inward direction, means into the screen. On the another one it is outward direction, means on CD arm it is the force is in upward direction, or in other words they were acting in the opposite direction. Force is acting on in the opposite direction, not along the same line. That means the force acting on arm AB and CD are equal and opposite. Force is same but in opposite direction and also not along the same line of action. Same line, and due to this reason they form a couple. It will rotate. Arm AB will move inward direction and arm CD will move outward direction. It will couple, it will rotate in anti-clockwise direction, in as we can see in the next picture. So our coil is moved. Now if you look closely, you will find that a time comes when the split ring S1 and S2 lose contact with the carbon brushes B1 and B2. Here there is no contact between B1 and S1, B2 and S2. So this is because the split rings, even through they are connected with carbon brushes, are not fixed with it. So while rotating there comes a time when there is no contact in between the carbon brushes and the split rings. no current flows through the coil. So there is no connection, means no current flow through the coil, so there will be no force acting on the coil. No current, no force. Now despite the fact that there is no contact in between the split rings and the carbon brushes, as you can see here, due to inertia of rotational motion, due to inertia of rotational motion, as it was moving from its initial stage, the coil does not stop suddenly and rotates further. So now see where the inertia of rotational motion comes to the coil next. So as we can see in our next picture here. Now the split ring S2 is connected across B1 and split ring is connected across carbon brush B2, which were earlier connected with B1 was connected with S1 and carbon brush B2 is connected with S2. Now it is opposite. Carbon brush B1 is connected with S2 and carbon brush B2 is connected with S1. So now after rotation, I consider the current direction of current. You will find that current flows through the coil in the direction DCBA from the positive terminal of the battery. Here current will flow in this direction from positive terminal of the battery to carbon brush B1 to S2 and to DCBA, and again come back through S1, B2 and to the battery. Current flow from D to C, here current flow from D to C and then from B to A. Now if I consider it with the previous case, you will find that despite the fact current direction remains same, as in the earlier case current is moving from here from B1 to in this direction. Now in this case it is also moving in the same direction in this way. It has reversed, but the current is reversed in the sense that previously it was flowing from AB, then from C to D, whereas now it is flowing from D to C and B to A. So reversal in this sense it caused due to the fact that we are using a split rings. We are using the split ring, that why the current is reversed. First of all, current was moving from A, B, C and D. Now it is moving from D, C, B, A. Current is reversed. The particular arrangement also known as this split rings. Due to this split rings, the current is reversed. We can say split rings or a commutator. The purpose of split ring commutators are, there are two purposes of split rings. The first one is to ensure that force act in the same anti-clockwise direction. The force acts in the same anti-clockwise direction. The coil will move in the anti-clockwise direction. The first purpose of this split rings. And the second purpose is to ensure that current remains same. It reverses in the sense of previously it was flowing from A to D. Now it is flowing as DCBA. Now consider DC and BA separately. First of all, consider DC. I placed my index finger and the index finger of left hand in the direction of magnetic field, and then I stretched out my middle finger in a manner to depict the direction of current along DC. So my middle finger uh, depicted the direction of the current in the upward direction. Now if I stretched out my thumb so that it is perpendicular to both my index finger as well as middle finger, I will find that the force acting on DC is acting in the downward direction. Now let us consider what happens at arm BA. Again, in the similar manner, I placed my index finger pointing in the direction which the magnetic field is pointing towards, and I placed my middle finger in the direction of current along arm BA. Now if I stretched out my thumb in a manner so that it is perpendicular to both index as well as the middle finger, I will find that the force acting on arm BA is in the upward direction. Due to this reason, the force is acting on arm DC and BA. It is forming a couple again. Which is in anti-clockwise direction. When electric current passes through a conductor placed normally in the magnetic field, a force acts on the conductor. When electric current passes through a conductor placed normally in the magnetic field, a force acts on the conductor. The conductor begins to move. Now in the next picture, here our conductor is in this state. Here our splitter S2 comes connected with carbon brush B1, and S1 is connected with carbon brush B2. So it has been rotated in the anti-clockwise direction. Current moves from D to C, B to A, and goes back to the battery. In this way our motor works in the anti-clockwise direction. Yes, but if we reversed, what happened if we reversed our polarity of battery? Means positive terminal of the battery, if we connect positive terminal of the battery to B2 and a negative terminal of the battery to B1, means we reversed our battery. What will happen in this position? In this way, in this case, our motor will rotate in the clockwise direction. So this is the actual picture of armature. Here a coil is pointed where is the insulated wire is wounded on a soft iron piece, and there are split rings. Here are split rings. This is the actual picture of armature. We can increase our speed of DC motor by increasing the number of coils. Here there are n number of coils, so the speed of this armature or DC motor will be more as compared to the one coil which we have done earlier. So there are split rings. Then each coil has two split rings. Each coil has two ends. One is connected to S1 and another is connected to S2. So there are pair of split rings. Here is the application of electric motors. Electric motors are connected in various appliances, electrical appliances such as ceiling fan, water pump, CD drive in computer, tape recorder, washing machine, mixer grinder, and electric toothbrush, etc. There are many appliances where our DC motors are used. This is a concept of a direct current. Here in the first diagram, electrons move from left side to right side, means from low potential to higher potential, from negative terminal to the positive terminal. Whereas in the second diagram, a current will flow in the opposite direction of the electron flow. Here in the second diagram, current will move in the opposite direction of electron flow from positive to negative, whereas electrons move from negative to positive and current move from positive to negative. So up to now we have done our DC motor, working of DC motor, application of DC motor, and speed of armature can be increased. However, speed of armature can be increased, increasing the current. First of all, in first case, increasing the current, and in the second case, increasing the number of turns of coil, increasing the number of turns of coil in the armature. Third one is increasing the area enclosed by the coil, increasing the area enclosed by the coil. And the last one is increasing the value of magnetic field, increasing the value of magnetic field. So this has done, up till now we have done DC motor and the concept of direct current, DC current. So along this video lecture, there is a PDF that is sent on the school app. In the school app,